I've got my friend here to help explain turn-based combat. He's quite friendly when he wants to be. On the right is me, the player. On the left is the final boss. In this case, he gets the first turn. When he uses an ability, it has an immediate impact within that turn. While the ability is happening, I get reduced down to a vegetative, idiotic state. I'm forced to just take the attack. It's like standing in the middle of a motorway, waiting for a truck to ram into you. The main tension comes from the question, will I survive this attack? Will I survive till my next turn? Well, the attack is a slipper, so of course not. But if I do survive, I'll have all the time in the world to think of a deep strategy. Oh, I'm dead. With real-time combat, everyone can attack at the same time. Oh wait, what's going on here?
まさか異世界？やばい、あの夢のスーパー男か。まったく。あれ？このカードはもしかして。
スタープラティナム。
まったく。
Persona? As you saw, tension now largely comes from reacting to an attack as it happens. I'm focusing on sequencing here because that's the only fundamental difference of these two systems. Everything else is down to the implementation. So, a single core CPU can only execute one instruction at a time. So, in real-time combat, if the player and the enemy attacks are going on simultaneously, they still have to be executed in some order, one after the other. In one frame, one slice of processing is for the player and another slice is for the enemy. Each slice is basically just a turn. So if I enforce an order to these processing slices, so for example, the player's processing slice must happen before the enemy's processing slice, it would make no difference to a real-time combat game, since the slices are so short. They're just a fraction of a frame. So even real-time combat can be viewed in a turn-based way. It's just that in traditional turn-based combat, the turns are so long that they contain an entire attack. And in real time, each turn is so short that you don't even feel it. They are the opposite extremes of each other on the same spectrum. The variable is just how long each turn is. Now, my hybrid system lies somewhere in the middle. To be extra clear, let me summarize. Turns will be shorter than they are in traditional turn-based combat, so attacks now take multiple turns by default instead of just one. If you throw a slipper, maybe it takes like 3 turns to land. During those 3 turns, you can use other abilities like moving or jumping into the air. Also, the enemy will probably try to dodge during that time. Is this too slowly paced though? Who has the patience for a slipper taking 3 turns to hit? Your parents certainly didn't. Well, this is just about balancing how much time each turn is, or how much time each turn represents. So this is the first code in the series. I could easily implement my idea as a text-only game in Python, but now I need to somehow translate that knowledge into Godot, the game engine I'm using. I won't assume any knowledge about game engines, by the way, since I have very little. Instead, I'll explain concepts as I go along. It's not going to be a tutorial series, so I am going to brush through things quite quickly, but it's just that I might have to do things in a Godot-specific way, and I don't want that to hinder people's understanding of what I'm doing. So I've forgotten the whole API. I don't want to rely on LLMs, as I said in devlog number 0, so it's time for everyone's favorite activity, RTFM. Read the manual. Yeah, this is gonna take ages. Instead, I'll code the 2 simpler systems and use those as stepping stones to implement the hybrid system. When you create a project in Godot, you get nothing apart from the Godot logo. It's beautiful. Okay, a quick guide to Godot. In Godot, nodes are the building blocks for everything. It's how the game engine exposes its functionality. Specific nodes do things like storing a 3D model, or handling collisions, or playing an animation. You can group these nodes together in a tree structure called a scene, and you store these scenes in a tscn file. So for example, I could have a player.tscn file, and that would have all the nodes needed to have a player. You need to have a main node just like a main file in ordinary coding. I need to add build and launch tasks since I'm coding in C# and I'm using an external editor. Here I'm using VS Code. To see stuff, we add a camera. By convention, it points towards -z. So to move forwards, you also need to move towards -z, instead of +z. This kind of makes sense, no it doesn't. For the player scene, the root node will be a character body 3D. It doesn't interact with the built-in physics engine, but it easily allows us to write code to do all the movement logic ourselves. In other words, I'll define how the player will move, not Newton and his damn 3 laws of motion. When I added the player, it was up there with the camera for some reason still being at the world's origin. The transform also said it should be at the world's origin. Turns out I'd actually moved the whole world, which is probably not a good idea. I'll add gravity to the player soon, so I need to make the floor collidable by adding a collision shape 3D. These shapes define how things collide. Remember how I said I needed to do all the movement logic myself? Well, that was a lie. Godot gave me a template script to control the player. I'll add a collision shape to the player and add some lighting, and now the player falls on the ground. If I remove the floor, the player now falls straight downwards. So far, all of this stuff is from my notes when I went through that 3D game tutorial on the Godot wiki. Everything from now on is stuff I didn't originally know. I either figured it out myself, or I searched it up online without using an LLM. For the weapon, I added the slipper I made. I made it a rigid body, so the physics is handled for me, forces, impulses, etc. Again, this needs to collide with things, so I added a collision shape. A bone attachment 3D allows me to keep the slipper's position relative to a bone on the player. Here, it's the right hand. For some reason, the slipper didn't move to the right hand. This is an example of why it is so much better not to use an LLM sometimes. Usually, I would have asked GPT why the slipper didn't move. Instead, I used my singular brain cell that constitutes 100% of my brain mass to figure out that, well, if the position is wrong, the transform must be wrong. And so it was. I figured it out all by myself. I'm giving myself a gold star. Unfortunately, gravity exists, and so the slipper will fall down. However, the slipper can transcend general relativity, so long as you set the freeze property to true. However, the slipper detected I was not worthy of possessing such a potent weapon of mass destruction, and judging by what operating system I'm using, I never will. It quite literally pushed me off the plane of existence. The issue is that it's fixed relative to the player due to the bone attachment 3D. However, it's no longer affected by gravity since I turned freeze on. Also, it's still colliding with the player's collision shape, so it constantly pushes the player to the left. I might solve this properly later on, but moving the slipper to the right seems kind of cool, so I'll just do that. I'll add a throw action. Since the slipper is a rigid body, we can do physics to it by applying an impulse, after we unfreeze it, that is. We'll just use the basis vectors of the player to make sure the directions are all correct. The enemy is pretty much just the same as the player, just without all the movement controls. We need to check for collisions from the slipper, and now it works. Anyway, enough real-time combat, time for turn-based stuff. I'm going to spend more time here on my thinking process and the theory, because once this turn-based prototype is done, the hybrid is pretty easy to implement after that. It wasn't, but let's just say it was. Firstly, you should have seen that the real-time combat system is a natural fit for these game engines. We can override the built-in process function that's called every frame, and so we change anything we want to at any point, just like in real-time combat. But turn-based combat doesn't really work like that. If this was a text-only game, I'd implement it as a while loop. Every iteration of that while loop is a single turn, and I could wait for player input without any issues. But in Godot, waiting for the player to select a move means that the game can't move to the next frame, so it freezes. Maybe you could solve this using threads, but I wouldn't know how to do that. Instead, what we need to do is split the work across multiple frames. The lectures I've had on the theory of computation have prepared me for this moment. We're going to use the state pattern. The idea of the state pattern is very simple. You have a variable that tells you the task you're doing, and then you do that task. Wow. Take a printer. It has two states. Idle, where we wait for the printing requests, and printing, where we actually print each line onto paper. In the idle state, once we get a printing request, we set the state variable to be printing. Then we'll do printing. Once it's done, we set the state variable back to idle, and so on. This allows us to split a task over multiple frames, such as our while loop from the pseudocode from before. But most of the time, just having the name of the state isn't good enough. It's like your boss telling you that you need to do work, without telling you what work you actually need to do. With printing, we need to know which line of the file to print. So actually, the printing state relies on additional state, the current line. So if our file has 50 lines, then I realize technically we have 51 states. We have an idle state, a printing on line 1 state, a printing on line 2 state, all the way down to a printing on line 50 state. 51 states is definitely harder to think about than 2 states, so we probably just use the 2 original states and rely on other variables to tell us what line to print on. Things may become more complicated though. From doing some research, we often need to do some kind of setup when we start a task and do some kind of cleanup when we end a task. For example, when we enter the printing state, we should check if we have enough ink. Update is a method where we actually do print things like we did before, and exiting the printing task, we make a noise to tell the user that printing has finished. I've often seen people create an abstract state class to model this, so each state has an enter function, an update function, and an exit function. So this means that we have the 2 original states from before, but each state now has logic on what to do when we enter or exit it. But this is actually just a specific case of when I expanded out the 2 states we had into 51 states. The enter function code for the printing state could be put into the printing on line 1 state. The exit function code could be written in the printing on line 50 state, and the update function represents all the other printing states in between. So I realized we can avoid the complexity of having enter, exit, and inheritance in general. Instead, we can turn enter and exit functions into their own states. We have an idle state, as per usual, but we also now have a printing enter, a printing update, and a printing exit state. Each state is now just a single function again, instead of 3. There is no inheritance anymore. We've increased the number of states from 2 to 4, that is true, but each state is now simpler. It's just a function. This time, I'm just going to show you what I've done overall rather than the step-by-step process, since I've explained the core logic already. Are you ready? These are the states, and this is what we do with them. Okay, once a player or enemy attack starts, we start a timer to wait for the attack to finish. In a real game, you could just do this with animations and then you would know when the animation finished. Anyway, to show that we're waiting, we set the current state to be the waiting state. We also need to wait when the player is selecting a choice of attack from the menu, but instead of having a timer, we just wait for them to click a button. When you do click the button, we transition states, starting the player attack. Finally, we need to restore where the player and enemy were each turn. Again, the combat in a real game would be more exciting than this, but remember, this is just focusing on the sequencing of events, not the actual actions. That's the next coding devlog. So how do we go from this to the hybrid system? Remember, the core idea is that moves by default take multiple times to land. In those turns, you can do other actions. I'm just going to make this prototype a 2-player game, have both players have the same abilities, and then just code them manually. I'll add a jump ability so players can dodge. I need to do a bit of refactoring to enable this, because right now everything is hard-coded just throw slippers. We're going to have an ability class. I know I should be using custom resources, but it's too late in the video to introduce a new Godot concept. The jump ability is quite easy to implement. We can just add a velocity vector which has an upwards component. We also need to pause the player when we're getting input from the player. If we are meant to pause in the process function, then we just don't do anything in the process function. But for example, let's say I've thrown a slipper, I need it to pause mid-motion. I need to have some kind of pause method on the ability class. So all that involves is just it's just setting the freeze property. To unpause the slipper, all we needed to have done is to have remembered the previous values of the linear and angular velocities, and then just to set freeze to be false. We update abilities after a player has selected a turn every frame for a set period of time. We check if they should be discarded, in which case they are discarded. Importantly, we don't have a restore method which puts the player back where they were at the beginning of the turn, since a big point of this is that this battle could lead them anywhere, pretty much. The battle is going to be very dynamic. I could explain the rest of the code, but I don't think there's any point. It's going to be kind of boring and the video will be way longer. I think what I've realised though is that the state pattern is a great way of succinctly expressing your understanding of a dynamic system, just by looking at the set of states you have and their transitions. So, as I've warned numerous times, this video did not focus on the actual abilities the characters will have in the real game, just the sequencing of moves. Now that we have the kind of sequencing in place, we can then focus on the abilities, and then when we have the abilities, then we can actually think about balancing this stuff. That'll be pretty important, because right now, no matter what player 1 does, they will always die. Jumping isn't good enough to avoid the deadly wrath of the slipper. I've given player 1 a false sense of choice. It's like driving slowly on the motorway on the left lane to bait the lorry behind you to go into the middle lane so it can overtake you, just for you to accelerate to prevent it from overtaking, accidentally driving into the hard shoulder, forcing you to get out the kid's bike, safety wheels on, obviously, cycle into the middle lane, where the lorry is approaching you, dodging the traffic like it's crossed the road, just to get slammed into the same truck you thought you had gotten the better of. If a frame represents a longer time period, then we start to approach turn-based combat, true turn-based combat. If the length decreases, then we start to approach real-time combat. Okay, just a bit of a reflection. When I started making this video, I was a bit scared that I didn't know what I didn't know. I felt like that if I got stuck on something, I'd have to pray that GPT wasn't going to hallucinate on me, or I just have no idea how I should solve something. But instead, the concepts I learnt from that tutorial that's on the Godot website, those concepts really did help. Everything else was pretty easy to search up if I didn't know. So, next week will be a music devlog actually, where I take a battle theme I improvise on piano and I'll make a jazzy version of it. The week after is where we'll actually be back to fleshing out this combat system in a coding devlog, so things like adding abilities, etc, etc. So yeah, thanks for watching and see you there. Bye. Just copy this just in case. You've read a lot of breakups. You really committed to the bit, the sigh, the cookies. If nothing else, you've got style. What? Like, okay, so when you patronize, when you gaslight me, okay, when Copilot gaslights me, it's okay, right? Right? CEO of Microsoft say, okay, it's fine, whatever, okay? When I gaslight you, I get this patronizing stuff. What? What?